Great. So hello, everyone, and welcome to this webinar entitled A Lyophilization Webinar That's Not So Dry: The Benefits, Challenges, and Best Practices of Freeze-Drying PCR Reagents. I think we've got a really interesting webinar lined up for you today, so it's great that you can be here. And now, before we get going, I just want to cover a couple of points. Firstly, there is a Q&A function on this webinar. So if you have any questions when we're running through the webinar, please use the Q&A button at the bottom of your screen to submit your question, and we will do our best to answer that question at the end in the Q&A session. The webinar is also being recorded, and the recording will be sent out to everyone who registered. So please feel free to watch the webinar again if you found it interesting, or forward it on to your colleagues if you think they would find it valuable. Now, before I introduce our speaker for today, I just want to introduce who we are quickly. So Medix Biochemica manufactures raw materials for IVD manufacturers. And Medix Biochemica started in Finland over 35 years ago, and since then has continued to grow and acquire new companies. And we now have offices in Finland, but also in America, in France, in Germany, in China, as well as a handful of remote staff scattered around the world. As I say, Medix Biochemica has continued to grow, and we now provide raw materials to almost all IVD manufacturers around the world. Now, you'll see that I've highlighted Constance, Germany here, and this is because this is where Medix MDX is based. And Medix MDX is Medix Biochemica's molecular diagnostics business. And we specialize in engineering unique polymerases for a wide range of DNA and RNA applications. And as well as providing off-the-shelf products, we also provide services like assay development services and lyophilization services. And that's why we're doing this webinar today. We really want to share some of our expertise in the area of lyophilization. So with that being said, it gives me great pleasure to introduce our speaker for today, Ksenia Lind. Ksenia is our Scientific Projects Manager at Medix MDX, and really one of our go-to people for all things lyophilization. So Ksenia, thank you very much. Please take it away.
Thank you, Rob. Thanks for the brief introduction. I'm Ksenia Lind, and I will walk you through the most important topics on lyophilization. So let's get right into it. What is lyophilization or freeze drying? It is a process to remove moisture from a substance via freezing and the application of vacuum. For the stabilization of it, you will most likely know freeze drying products from pharma or the food industry, but it can also be used to stabilize biological materials, or in our case, lab reagents. The main steps of lyophilization is freezing, then primary drying and secondary drying. And I will talk about that in more detail in the following slides. But before we start with that, I would like to tell you a little bit about the advantages of freeze-dried products for manufacturers or even end users. So lyophilized products have an enhanced product stability, especially for sensitive reagents, and we don't need to extensively heat those reagents to have this product stability. You are being able to store them at ambient temperatures, which is especially useful in diagnostic testing, like in point of care or in low resource settings. It eliminates the need for refrigeration, so it reduces the cost and the logistical challenges associated with cold chain shipping and storage. And this flexibility provides us to do diagnostic testing in remote areas where it otherwise might be unavailable. It gained a lot of popularity of lyophilizing PCR reagent while the COVID pandemic. This is, first of all, due to the fact I told you before, so you have been improved shelf life stability, and simplified transport, but it also improves a lot in terms of convenience. So if you have a lyophilized product, you can use it directly while resolving it with your sample if you have a direct PCR approach, or you can resolve it in an extracted sample and put it in the cycler and get your results immediately. So it reduces the likelihood of errors since it simplifies your workflow. And in these times of high throughput testing, it is really important to come back to very simplified workflows to eliminate or reduce the likelihood of errors. But lyophilization can not only be used in IVD, it can also be used in agriculture, food safety testing, veterinary medicine, for example. So it's not only for point of care, but also for point of need. And lyophilization can definitely help in these parts. There are a lot of different types of lyo products, and we are aware through our customers that there is a lot of confusion behind it because they differ quite significantly from each other. And I will walk you through these different types of lyo products and give you a recommendation which type of product to use in different stages of diagnostic assay development. So we have lyo-compatible products, lyo-ready products, and the lyophilized products themselves. Lyo-compatible products are, for example, enzymes in a liquid format that have low or no glycerol content, which means they are, for example, enzymes that retain the characteristics of conventional enzymes. So they have the same reproducibility, sensitivity, and specificity that is required for a diagnostic assay, while being delivered in a format that is lyo-compatible, for example, with a low glycerol content. I would recommend to use such lyo-compatible products if you want to maybe lyophilize in the future, but you are still not sure, and you want to eliminate the risk of changing your enzyme in a later state of your development, or even changing the formulation in a more drastic way. Then we have lyo-ready products, for example, a master mix in the liquid format that does not need any additional excipients to be lyophilized. So you have the advantage of flexible assay design. You can do in-house lyophilization just by adding primers and probes, and then have already an optimized reagent composition that is typically low risk and straightforward to lyophilize itself. So the robustness and stability of the product is not really impacted if you are adding primers and probes. The lyophilized products themselves are customized solutions for specific application. So you give it into the hands of an expert to do the formulation. In this case, we would take care of sensitivity and specificity of the diagnostic assay and lyophilize it and package it in a way that you envisioned. The advantage is that you profit from the experience on freeze drying, and we will ensure that the product is really dry and stable at room temperature. So since there are so many different types of products on the market, why don't we just lyophilize everything? What are the challenges behind lyophilizing PCR reagents? The biggest challenges that we face, especially compared to bulk pharma productions, for example, are that we are lyophilizing smaller volumes and in different primary packaging. So when in pharma, we often use glass. In our industry, plastic is more frequently used, single-use plastic also. And the primary packaging and the product format decision play a significant role in the lyophilization process. So they are often not trivial because you need specific equipment for dispensing, drying, and packaging. Then we often lyophilize not only single components, but mixtures. And in these mixtures, there are active proteins present, which we must protect from the lyophilization process itself. They still need to be functional afterwards and not decrease in their performance. They have buffering systems, which often come with low collapse temperatures. So we need special equipment to achieve these low temperatures. And we have the challenge of introducing mostly excipients to change the formulation and promote sublimation and protect those enzymes. When you have a dry product afterwards, you need to protect it from humidity. So you also need here special equipment to get your dry product out of the lyophilizer. So I already told in very brief how do we overcome such challenges, but I want to go into more detail, especially in terms of excipients. So what are they and why do we need them? The choice of excipients is based on the requirements of the final product and what qualities and sensitivities of the active ingredients we have. So for example, when we talk about small molecules, for example, salts, we often have low transitional temperatures, which may require thermal stabilizers that increase the transition temperature into a range that we can reach with our equipment. If we talk about biomolecules, for example, like enzymes, which are huge, they often need lyoprotectants and they need to be stabilized during the freezing and drying process. Since we are removing water with the lyophilization, these water molecules are essential for the 3D structure of the active ingredients and also ensure the activity of these ingredients. So we need to protect them in the process. Common excipients that we use can be divided in different categories. So I told you already about the thermal stabilizers, for example, dextran or PEG. And these excipients are added in order to improve the thermal stability during the processing. So the aim is to increase the transition temperature of the formulation. Then we have lyoprotectants. They are typically saccharides or polymers, and they are required for proteins. Some lyoprotectants work better than others, depending on the enzyme or the protein itself, but this also depends on the freeze-drying conditions and what else is in the formulation. Two common excipients I haven't told you about before. These are the bulking agents, for example, mannitol or lactose, so also sugars. And these bulking agents may be added to enhance the physical properties of lyophilized materials. So we are talking about appearance and cohesiveness of the product. Buffering agents, I think, are self-explanatory. They are buffering, therefore they are here for buffering. And as you can see, some of the excipients fall into more than one category. For example, like dextran, or we have sucrose also, mannitol, which are very commonly used. And you don't need to incorporate every type of excipient to get a high quality product. But the more you introduce, the more complicated this process gets. So you have to choose wisely based on the requirements of the final product. So these are the additives that help us to lyophilize, but there are also no-go substances. For example, glycerol, which are present in most enzyme mixtures. So here it is important to use at least lyocompatible products that have this low glycerol content. so you don't face the issues or the problems that you get when you want to lyophilize something with glycerol in it. Then we have also volatile components that may be removed by freeze drying. So you have a resulting higher pH than your starting material, which is also not optimal. Organic solvents, for example, DMSO or something like that, is also quite problematic. And ammonium sulfate, we also face quite often difficulties with that. But it always depends on how much you put in it. The equipment that is needed for lyophilization is often quite costly and needs also to be chosen wisely, because it depends on what you want to have in your final product. So if we are talking about big batch sizes, then you need a lyophilizer that is quite big, and you also have lyophilizers that have different types of temperature ranges that they can reach. So this is depending also on the collapse temperature of the formulation that you want to lyophilize. So for example, on the left side, you can see one of our lyophilizer that is especially used for lyocake production. We can lyophilize their very large batch sizes. Several thousand of single PCR reactions can be lyophilized at once, which of course reduces the cost of large batches. On the right side, you have the Advantage Pro, for example, which is especially used for lyobead productions, since it can reach lower condenser temperatures. And here we can also produce several thousand single PCR reactions at once per batch. So we talked about formulation, what are no-go substances, what equipment we require, and I want to talk about science, or at least the theory behind it, how freeze drying takes place. So we have 3 different stages of lyophilization. First, freezing, then primary drying, and afterwards secondary drying. The product in freezing is frozen with cryoprotective excipients at temperatures of approximately -40 degrees, which sounds quite easy, but it really isn't. So you can reach this -40 degrees in different ways. If you are doing gradual freezing, which would usually provide maximum efficiency for lyophilization, this forms large ice crystals that are easy to sublimate afterwards, but these large ice crystals can disrupt and damage the materials that are structurally sensitive. So in this case, you are using more rapid cooling to have smaller ice crystals. And you have to keep in mind, we are mostly working here with enzymes that are very large biomolecules and very structurally sensitive. So you have to find the middle ground between rapid and gradual freezing. Afterwards comes primary drying. It is the removal of bulk solvent like water by sublimation. And I'm pretty sure that most of you have already seen some type of this diagram. So this is the amended phase diagram for pure water. We often don't lyophilize pure water, but we still use it. So the sublimation, what the diagram shows is the different stages of water that it can take in consideration of temperature and pressure. So we have liquid, solid, and vaporous states. And in the first part, we go from liquid to solid in the freezing part, and then afterwards, in primary drying, we have the sublimation in the left corner. And this is the change in state directly from solid to gas. So since we work with mixtures and all these components behave differently, we need to stay a lot lower below the triple point of water. So we reduce the pressure below the triple point and then apply a small amount of heat to energize and free the ice crystals to undergo sublimation. And this transition from a glassy frozen state into vapor. It removes approximately 95% of the water, and we have a largely dry powder or adhesive form like a cake or a bead, for example. Afterwards, the third stage comes, and this is the secondary drying. It is the removal of solvent like water by desorption. In this final step, we remove unfrozen water molecules that are absorbed, associated, or bound to the product. And the temperature is increased a little bit higher, disrupting this interaction between the water molecules and the frozen material, and then removing it through desorption. Since this is an equilibrium-based process, secondary drying tends to become less efficient over time. So this stage will be significantly shorter than, for example, in primary drying. Here you can see a simplified example of a lyophilization program. So we have here first the freezing stage, and how rapidly this stage is in your lyophilization program is highly depending on what you are lyophilizing. Afterwards, you apply a vacuum, and then sublimation can take place. So we remove about 95% of the water of the product. And then secondary drying starts, so we heat again a little amount higher, and then we remove the associated and bound water to the product. As a result, we get something that is in a cohesive form or a powder, which is lighter in terms of mass and smaller in volume than the original product. These lyophilized products can come in different types of forms. So, for example, we have lyo cakes or lyo beads. Lyo cakes look typically like that, or in a larger volume or bulk format, like here in this picture. And lyo beads are typically this circle form. They come in bulk or in a single reaction format, and they differ just in what you lyophilize them in. So lyo cakes, for example, like here, are lyophilized directly in the plastic that you want to use. So you have the advantage that you already you have already aliquoted your product. It's in the plastic that you want to use, and it's lyophilized directly in there. For lyo beads, for example, you can also just transfer it afterwards. So they are not lyophilized in the plastic that you want to use afterwards. So you can choose afterwards where to put them, transfer them, and they can be placed, for example, in cartridges, which is especially useful in point-of-care testing. Some lyophilized products may appear powdery or crystalline-like, so we get the question often if they are delicate. But I can assure you that they will remain intact even if they are agitated. So a high-quality lyophilized product will remain in the form that it is in, even if you tap it or if you are shipping it, which is mostly also not like a client process to undergo such product. So when you're getting a lyophilized product back into the liquid form, it is a process called reconstitution, where you simply add water or your appropriate buffer or even your sample. And this solution is then ready to be used. To summarize, lyophilization is a process to remove moisture to stabilize it. And the challenges that you will face if you want to lyophilize is that you need special equipment, and choosing the right formulation really requires expertise. But after lyophilization, you have improved stability and shelf life. It is easy to store and to ship, and you have simplified workflows. And additionally, you have a lot of products to choose from as a starting point, from lyo-compatible or lyo-ready products. So if you have the equipment, you can just lyophilize in-house without the need of expertise for the formulation itself. So that's it from my side. I would like to hand back to Rob.
Great. Thank you very much, Skenia. That was brilliant. So now we'll move on to the Q&A session. So I'd like to introduce two more of my colleagues. Firstly, Dr. Giuseppina Sanino, who is Medix MDX's Global Business Development Manager, and also Dr. Ramon Cranasta, who is Medix MDX's Head of R&D. So welcome to you both, and let's jump into the questions. So let's start. Maybe a question for Giuseppina, if you're there.
Yep. Hi.
You mentioned lyo-compatible, lyo-ready, and lyophilized products. Do you offer products in all three formats?
So yeah, thanks for this question and everyone for joining this webinar. Yeah, the question, so the answer to this question is yes. So we may not have directly out of shelf all these format for all the products, but we work a lot with our customers to provide customized solutions. So you can look in our products, and if you don't find exactly the format that you need, we can make it for you and work together to develop the SE. So yes, we have expertise for all three formats, basically.
Brilliant. Thanks. Now maybe a question for Ksenia or Ramon. How do you select the correct combination of sugars, lye protectants and bulking agents? What's the maximum sugar percentage suitable for freeze drying?
It's not that easy to answer this question. It highly depends on what is in the mixture, and especially in terms of components. So if you have something with a lot of salts in it, you definitely need more. And then the question is, if you want to protect, for example, your enzyme, you often need also in combination something that is a bulking agent. So it really highly depends. I cannot answer this question just without looking at the formulation itself.
Okay.
Yeah, I may add something as well. I totally agree to Ksenia's answer. I would just add, in this case, I would always recommend to look into literature. What have people been doing with the similar components mixture, and then try that first. It's a lot of trial and error as well. However, also then you need to look how much are these excipients interfering with the test itself, with the function. So you have to look at that. Plus, on the other hand, you want to add something into it, not just to stabilize, but also to have more stability in the cake itself, especially when we talk about the lyo beads. They need to be also having a stable structure so they don't break apart straight away after freeze drying and so on. So that's why Ksenia was mentioning the bulking agents. They have also this function that they just stabilize the cake or the bead in that case. So that it's there's for sure not a simple answer to it. That's for sure.
Yeah.
Brilliant. Okay, thanks. Got another question here. What is the best way to make your lyophilization faster? shorter the main drying?
It also depends on what you are lyophilizing. I'm sorry, I think this will be the answer for all the questions. But yeah, you can always shorter your primary drying step and your secondary drying step. I think I would not change anything in the freezing part, which is very crucial, and the primary drying. It's also highly depending on what your requirements are. So if you are reducing the time significantly, you will face the challenges that your product will not be as dry as previously. And yeah, but I would recommend to try it with the primary drying phase. But yeah, it is complicated. Yeah.
There are technologies now where you can like have in the freeze dryer there are certain probes you can apply and then look when the freeze drying the first stage is kind of finished. Yeah, so you can look into that with what is this, for example, like a balance. It's all the time weighing the product in it, and once the weight doesn't change anymore, you know, okay, now we reached the end of the first phase, and then you can go into phase 2. So you have to look into that. That's something you can probably do if you have such an instrument. That's possible. And then the freezing, yeah, as Xenia mentioned, if you freeze too fast, you get different crystals, bigger or smaller crystals, and they are already giving you different lyophilization result at the end.
Yeah.
The transport of the water molecules through these ice crystals are then faster, slower, and so on, and that can all make a difference. Yeah.
Brilliant. Okay.
Also, the difference, maybe what also could speed up it a bit if you increase the difference between the shelf temperature or the product temperature and the condenser.
Yeah.
Not just I think you cannot speed much up with the vacuum. You could say it's, yeah, I mean, it's more, you would assume you go lower with the vacuum and then you get faster lyophilization process, but that's usually not working out. But rather making the temperature gap between what I mentioned is probably more critical. So you could speed up that as well. And then yeah, you have to just shorten and see what happens, I believe. And with freeze drying, it's not so much theory rather than trying it out.
Yeah. Yeah. So this trial and error phase, you will get that everywhere. You cannot jump ahead of it. So if you have more expertise, you can definitely shorten this time of trial and error, but it's still involved. This is just part of the process.
And best is for sure look into the literature, have something what people have been doing successfully already, try to adapt their protocol first and then start from modifying it from there if you get something working. That's my recommendation here.
Brilliant, thank you. Question here for Giuseppina. Do you have any lyophilized products suitable for the point of care?
So at the moment we do not have it out of shelf, but we have an isothermal enzyme, which is called isotherm 3G, which is able to amplify both DNA and RNA at the same time. And we have been working with different customers in lyophilizing this enzyme as lyopits for using it in point of care devices. So yes, we have it, and we customize it based on your needs and your requirements.
Great. A question for Xenia and Ramon. I'm interested in also lyophilizing a positive control in my mix. Is this possible?
Yeah, so I think we're talking about templates, so just larger oligos than typical primers and probes, which are low risk in incorporating in a formulation that is already optimized in for lyophilization. So this should be no problem.
Great, great. And we're running behind on time, so we'll probably make this one the last question to Xenia and Ramon again. lyophilization has been around for a number of years now. Where do you see this area going in the future? What improvements do you think will be made?
Yeah. So lyophilization is around a long time, but I think how important it is, especially in lyophilizing PCR reagents or applications for LAMP, is gained a lot of importance in COVID and the recent years. So I think definitely when taking point of care into consideration and testing in remote areas or from personnel that is not really trained, I think this will gain a lot of popularity even more and will become more relevant. Yeah, so.
Brilliant. Okay, well, unfortunately, we have run out of time. If you did submit a question and we didn't get around to answering it, don't worry, we will be making a complete list of questions and answers and sending that out to everyone. So you'll get your answer. I would just like to thank Xenia for the speech earlier, and thank you to Giuseppina and Ramon for helping out in the Q&A session. And thank you to everyone who came. I hope you found that valuable. Have a brilliant day.
Thank you. Bye.
Thank you.
Bye.
Bye.